My dear friends, today my topic is what is a magnetic field at some point due to a current element. You know one thing, the basic source of magnetic field, the reason of magnetic field. Okay, the reason of magnetic field is a current. Whenever there is a current, there will be magnetic field. Like in case of an atom, electron orbits, suppose like a hydrogen atom. The one electron is orbiting, maybe clockwise, maybe anti-clockwise, no problem. And electron orbiting, electron is a charge. Charge in circular motion, when it is a current. And if it is a current, there will be magnetic field. So that atom, hydrogen atom, one electron which is orbiting, that atom behaves as a magnet of its one face north, other face south, like a tiny magnet. So this is the basic reason of the magnetic field. Okay. Now, in this article, in this law which I am going to discuss, we'll find the field at some point because of the current which is flowing in magnitude and direction. So, please, if you like my video, then subscribe my channel, okay? And moreover, if you want to ask any questions, if you want mind, I'm giving you my WhatsApp number 9888169226. You may ask, no problem. You put a message, okay, using WhatsApp number. But please subscribe. Thank you very much. Let's come with me for this law. So we are discussing Biot Savart Law. This law is also called Ampere's law and also called Laplace's law. Okay, Biot Savart's law, Ampere's law, Laplace's law. Now what it is actually? So we consider, this conductor of any arbitrary shape. This shape is arbitrary. Okay? And then some current is flowing in this direction. The current is flowing at SI. You know very well current is a scalar quantity. Now we consider a very, very small element, very, very small length of this conductor. Small length is called length element. How much? dl. Now dl length, actually length, this is scalar, but it becomes vector when current attaches with it. Okay, when current multiplied by dl, current will tell the direction of dl. Current decides the direction of dl vector. Length becomes a vector quantity when current gets multiplied with it. जब करंट स्केलर है ना, लेंथ भी तो स्केलर ही है, पर यदि लेंथ को डायरेक्शन दे दी जाए तो फिर लेंथ वेक्टर बन जाएगी. तो लेंथ को डायरेक्शन कौन देगा? करंट देगा. करंट आइडियल वेक्टर इज अ वेक्टर क्वांटिटी कॉल्ड करंट एलिमेंट. Okay. Now our problem is, what is the magnetic field? What will the field at this point? What will the magnetic field at this point? Now we take the central point of this length element. Central point of the length element is point C. Okay, and we are interested here. I join C to that point. And now this vector, it is called R vector. And its direction is outward, okay? Increasing in outward direction. So this is our R vector. And we are interested here what is magnetic field. Okay. Now it is very clear the field, because field is related to current. And because the length element is very small, the field will also be small. Small field is written with dB. So dB will be proportional to number one, what is current, the magnitude of the current. If the current is small, field will be small. Current is high, then the field will be high. And proportional to dl also, the length element. Okay? Or you can say the field is proportional to current element, IDL. Right? Now, if you are very near, you are near to length element or current element, then field will be strong. If your point is here, the field becomes weaker. If here, the field still becomes more weaker. Mean the field gone decreasing as you are going away from the center of the length element. The field will go on decreasing in magnitude. Okay, the field value will go on decreasing. And the field which is decreasing with increasing R, it follows the inverse square law. When dB is inversely proportional to 1 over R square. Okay, R increases, dB decreases. Now then, this next point is very, very important. You know, if your point is here, if you take the point at here, you may consider the point here, you may consider the point here. But one thing you noted, if we consider this point, even the R is R in magnitude, like this value of R and this value of R, it is the same. Current is same, length element is same. The field, but the field will decrease. If you consider this point, even from here to here, the magnitude of R, I'm not talking direction. Direction of R is changing. Because if this is a point, this is R vector. This is a point, this is R vector. This is a point, this is R vector. I'm talking magnitude. So this magnitude, this magnitude, this magnitude, they are the same. Length element is same, current is same. But here the field is more, here it decreases, more decreases, more decreases, gone decreasing, decreasing, decreasing. If your point is on the length, the field becomes 0. And if your point is exactly at 90 degree to the 90 degree to the this current element, okay, if your point is at 90 degree to the current element, the field becomes maximum. That means field depends upon the angle. Okay, what is the angle? So if angle is 90, this angle is 90, this is less than 90, decreasing, angle is decreasing. Okay, angle is decreasing. 90, you know, from here to here it decreases, decreases, decreases. And if you are on the length element, then the theta becomes 0. And you will find no field at here. No field exists on the length element. Field exists maximum at 90 degree. So, you know, sine theta, it is a very good function. It tells the same. Mean if theta is 90, sine 90 is maximum equals to 1. And if you are on the length element, theta equals to 0, sine 0 equals to 0. So dB also proportional to sine theta. Now combining all that, dB proportional to IDL, inversely proportional to R square, directly proportional to sine theta. Now combining all, so it becomes dB proportional to IDL sine theta upon R square. Replacing proportional sign by a constant, and the value of constant is mu naught upon 4 pi. Why mu naught? This is very, very important, because mu naught is a parameter which changes with the space in which your current element is. Mean if like this is a current element, ideal, and this is our point P. So if you are doing the practical, you are performing experiment in the free space or in the air or in the vacuum, then mu naught upon 4 pi, its value is, mu naught upon 4 pi, its value is 10 to the power minus 7 in SI system. Or you can say mu naught is 4 pi into 10 to the power minus 7 in SI system. Mu naught is 4 pi into 10 to the power minus 7 in SI system. So this equation for you, please tell me how this unit comes and how this unit comes. So these are two questions, okay? Write me in the comments box. So for the free space or air or vacuum, this K replaces with mu naught upon 4 pi and its value is 10 to the power minus 7. But if your space in which the current element is, it is different from, like it is not the free space, it is water, it is any other medium, okay, then this value will change. Don't think it is always constant. It is not the universal constant. It changes with the medium. Mean this mu naught is medium dependent. Okay? Or you can say the formula of the field becomes mu naught upon 4 pi ideal sine theta upon R square. This that the field depends upon the medium in which you are performing the experiment. You are finding the field, that medium where you are finding the field. Field is proportional to ideal. It is proportional to sine theta, inversely proportional to R square. Now next it is, A vector cross B vector. It is AB sine theta, the magnitude of the cross product is AB sine theta. If I write A vector cross n cap, A vector cross n cap, then it becomes A. N cap is a unit vector. The magnitude of unit vector is 1. So A into 1 into sine theta mean A sine theta. So A sine theta mean magnitude A vector cross n cap. So similarly, because I am having here I dl vector sine theta, okay, then how I write I dl vector sine theta with like A sine theta mod of A vector cross n cap. So here I write mod of A vector. A vector mean I dl vector cross n cap. N cap I write here R cap. So ideal sine theta can be written as mod of ideal vector cross R cap. Okay. Now, when you are writing in a vector form, then don't write like magnitude. Okay? It becomes mu naught over 4 pi. I dl vector cross r cap. I explained here how it comes. But I'm not writing magnitude because I'm writing in vector form, dB. So dl vector cross r cap upon r square. Now unit vector can be written as r vector upon magnitude. So this r cap is replaced by r vector upon r. So the formula becomes here in the denominator, it comes q. Okay, and in magnitude form you take the magnitude of this. Right? Here it is a vector and it is r cube. Okay, lastly, what about the direction of the field? What about the direction? Okay, this was my current element, ideal, and here it is angle theta. Okay, field at here, at this point. Theta is the angle between ideal and r vector. As Biot Savart law is dB equals to mu naught upon 4 pi I dl vector cross r vector upon r cube. Now what is the direction of dB vector? What is the direction? So it is perpendicular to this plane. And what is this plane? This is ideal, this is r vector, this is our plane. Okay, and field will be perpendicular to this plane. Perpendicular means it may be like upward or it may be downward in direction. Mean perpendicular to this plane, it comes, perpendicular is like, this is perpendicular, vertically up or vertically down, vertically up or down. Now then how we decide whether it is up direction or down direction? Okay, if it is down direction, we put it here a cross. Cross means perpendicular and down. If it is vertically up, then we put it here a dot. Okay, like. So here it will be cross or dot. Cross means down direction, perpendicular down. Dot means perpendicular and outward. Now, you may find by this right hand, by the screw rule or right hand thumb rule. What is the screw rule? Mean you rotate the screw according to this sense, ideal and r. This is ideal, this is r. Mean you turn the screw like this, mean like this. Turn the screw like this. Okay. If you turn the screw like this, because first this is sense, ideal, then r, mean ideal to r. This is clockwise rotation. When it is clockwise, the screw will advance in inward direction. Okay, मीन जब हम स्क्रू को घुमाएंगे ना ऐसे, तो ये क्लॉकवाइज है. जब क्लॉकवाइज स्क्रू घूमेगा तो वो अंदर जाएगा perpendicular and inward. Then mean the direction is cross. Here you put the cross. Cross means downward, perpendicular and downward. Okay, so this is how we decide the direction. You may use for finding the direction right hand thumb rule. Okay, that will tell you the direction at here because of the magnetic field because of the current element, the direction of field. Okay. So this is all about Biot Savart Law. Please subscribe my channel. तू शाही है, प्रवास है काम तेरा, हवा में उड़ना, तूफान अंधेरियों को चीरना। तू शाही है, प्रवास है काम तेरा, तेरे सामने आसमां और भी हैं, तेरे सामने आसमां और भी हैं।